Tatar, a system professor in the Chemical Engineering Department of LJIT Ahmedabad. In this lecture, I am going to start new topic of the mass transfer operation 1. So let's start. You can see on the screen, chapter name is mass transfer coefficients and topic is convective mass transfer. So in this chapter, we are going to study different types of the mass transfer coefficients. I told you in last lecture as well, there are different types of the mass transfer coefficient such as local or individual mass transfer coefficient and overall mass transfer coefficient. Okay, means local and individual mass transfer coefficient means that is represented by small kl or small kg. Small kl means the mass transfer coefficient or individual or local mass transfer coefficient in the liquid phase. Similarly, kg, that is nothing but small kg is the individual or local mass transfer coefficient in the gaseous phase. After that, we are going to see in next lectures overall mass transfer coefficients. We are going to derive relation for the overall mass transfer coefficient. But before that, you should know concept of convective mass transfer coefficient. So you can see on the screen now. First of all, mass transfer by convection involves the transfer of material between a boundary surface and a moving fluid between two relatively immiscible moving fluids. Here, boundary surface such as solid or liquid surface. Means here convection involves between the transfer of material between the boundary surface and any moving fluids. That is nothing but mass transfer by convection. Means here boundary surface also involved and any moving fluid also involved. Then I can say mass transfer by the convection. After that, you can see on the screen, there are two different cases of the convective mass transfer. I can say there is intraphase or interphase mass transfer coefficient. I will discuss with you meaning of intraphase and interphase in next slide. But before that, you can see on the screen, there are two different cases of convective mass transfer coefficient. First one is, you can see on the screen, mass transfer takes place only in a single phase, either to form or phase boundary as in a sublimation of naphthalene solid form into the moving air. Means here mass transfer takes place only in a single form. Naphthalene is sublimated into the moving air. That is nothing but sublimation, means solid form is directly converted into the air, or I can say vapor form. That is nothing but sublimation of the naphthalene solid form into the moving air. Okay, so this is the first case where mass transfer involved in only single phase, and that is nothing but intraphase. Okay, and you can see on the screen, second type is mass transfer takes place in the two contacting phases as in extraction process. Now it's time to learn what is the meaning of intraphase and interphase mass transfer. I told you in last lectures as well what is the meaning of intraphase and interphase. There is a difference between these two terms. This difference can be asked in your viva or interview, that intraphase and interphase, there is a difference. And intraphase means mass transfer occur within the single phase. That is the first case of the convective mass transfer. Means mass transfer, there is a movement of the molecule from the higher concentration region to the lower concentration region only in a single phase. That is nothing but intraphase mass transfer. And second one is interphase mass transfer. There is a movement of the molecule from the higher concentration region to the lower concentration region between two phases. Okay, in that cases, interphase is involved. We are going to study interphase concept, or I can say two film concept. Okay, in coming slides, but before that, you can see here there are two cases. First one is intraphase and second one is interphase. Intraphase means mass transfer occur within the phase, and interphase means mass transfer occur between the phases, or I can say mass transfer occur more than one phase. After that, now we will see convective mass transfer coefficient. In this concept, we are going to study concept of heat transfer and mass transfer. There is a heat transfer coefficient that is represented by H, and there is a mass transfer coefficient that is represented by K. So what is the difference between this? You can see on the screen, in the study of convective heat transfer, the heat flux, that is nothing but Q by A, okay, is connected to the heat transfer coefficient. So you can see this is the formula for that heat flux. Q by A, that is nothing but Q, small q, that is the heat flux, okay, or I can say Q is nothing but heat transfer per area, that is represented by small q, that is heat flux, is equal to H in bracket Ts minus Tm. According to heat transfer, we know that heat is directly proportional to the temperature difference. Okay, but in mass transfer, I told you that there is driving force for the mass transfer is a concentration difference, and driving force for the heat transfer is a temperature difference. Means whenever there is a temperature difference is available, then and then there is a heat transfer possible. In mass transfer, whenever there is a concentration difference available, then and then there is a mass transfer possible. So you can see on the screen, convective mass transfer coefficient, in that first system is the heat transfer. In heat transfer, we are having this formula Q by A, that is Q is directly proportional to the temperature difference, that is Ts minus Tm, and here proportionality constant, that is nothing but H, small h, that is your convective heat transfer coefficient. Now analogous behavior, that analogous behavior in the mass transfer, you can see on the screen. The analogous situation in the mass transfer is handled by an equation of the form. This is the equation. Na is directly proportional to the CAS minus Ca. What is the meaning of this? Means here molar flux is directly proportional to the concentration difference. What is the molar flux? Molar flux is represented by Na. And I told you there is a difference between diffusion coefficient and molar flux. Okay, diffusion coefficient is represented by DAB, or I can say DBA. What is the meaning of DAB? Diffusion of component A through the B. And what is the meaning of DBA? Diffusion of component B through the A. And here Na is nothing but molar flux of the component A. So this molar flux of component A is directly proportional to the concentration difference, that is a CAS minus A. What is the meaning of CAS? Concentration of component A at the surface, boundary surface, and Ca is concentration of component A in the bulk phase at any point in the phase. Okay, and here Kc, this is nothing but proportionality constant in the mass transfer. In this situation, in this analogous behavior, in this Kc is nothing but your convective mass transfer coefficient. So here two terms are very important. First one is a small h and second one is Kc. So h is nothing but mass heat transfer coefficient and Kc is nothing but mass transfer coefficient. This question, this simple question can be asked for 3 marks in your examination or can be asked in your GATE examination. So what is the convective mass transfer coefficient and what is the analogous behavior in heat transfer? So this is the simple answer. In heat transfer we are having convective heat transfer coefficient, that is a small h. In mass transfer we are having convective mass transfer coefficient, that is Kc. And driving force for the heat transfer is a temperature difference, that is directly proportional to the heat flux, and heat flux is represented by Q. Okay, there are two different fluxes. I am repeating. In heat transfer we are having heat flux and in mass transfer we are having molar flux. So molar flux is nothing but Na and heat flux is nothing but Q. Okay, so these are the important terms and this question can be asked for 3 marks in your final examination. After that you can see on the screen the molar flux Na is measured relative to set of axis fixed in a space. Means we are going to see now the meaning of Na. Na is nothing but molar flux of component A. So you can see here now, I told you for the mass transfer, driving force is nothing but concentration difference. Okay, and we have taken in the previous slide CAS minus Ca. CAS means concentration of component A at the surface and Ca is nothing but concentration of component A in the phase at any point. So you can see now, the driving force is the difference between the concentration at the phase boundary, that is represented by CAS, a solid surface or a fluid interface. I will discuss with you concept of interface in the next slide. Okay, before that you can see here CAS is nothing but concentration of component A at the solid surface or fluid interface and the concentration at some arbitrarily defined point in the fluid medium, that is a Ca. I told you CAS means concentration of component A at the surface at any point on the surface, and Ca is nothing but concentration of component A at any point in the medium, or I can say bulk phase of that system. And this difference CAS minus Ca is nothing but driving force for the mass transfer. Okay, next one is the convective mass transfer coefficient Kc. I told you for mass transfer we are having convective mass transfer coefficient and for heat transfer we are having convective heat transfer coefficient. So convective transfer coefficient is represented by h, small h, and convective mass transfer coefficient is represented by small Kc. In coming lectures I am going to discuss with you overall mass transfer coefficient. But you can see here the Kc is a function of geometry of the system and the velocity and properties of the fluid, similar to the heat transfer coefficient h. Now here we are going to see what is the meaning of interface. I told you if there is an interface mass transfer coefficient. Before that you should know that interface is not involved in intraphase mass transfer. Means if you are having only single phase mass transfer, there is no need of the interface to separate the phases. But there is available of the surface boundary. That is not known as the interface. Interface is involved to separate the two different phases. For example, I am taking two phases example of the gas absorption. In gas absorption, I am removing some component from the gaseous mixture by using liquid stream. So here gaseous phase is separated from the liquid phase by using interface, and across the interface on the both sides there is availability of the two films. In the gas phase there is availability of the gaseous film, and on the liquid system, on the liquid side there is the liquid film, and the concentration at any point in the film is different rather than the concentration at any point in the bulk phase. Okay, and that separation of the phases is represented by the interface. So interface concept is involved in interface mass transfer. Interface mass transfer means there is a mass transfer between the two phases, and interface means there is a mass transfer within a single phase. So this is the concept of the interface mass transfer. So what we have seen in this lecture, I have discussed with you what is the meaning of convective mass transfer coefficient and what is the meaning of convective heat transfer coefficient. I am repeating, in heat transfer we are having small h, that is heat transfer coefficient, and in mass transfer we are having analogous behavior, that is mass transfer coefficient. There is a relation, two important relation in the mass transfer we are having, that is NA is directly proportional to the concentration difference CAS minus CA, okay, and proportionality constant is a mass transfer coefficient, that is Kc. But in heat transfer we are having flux Q by A is directly proportional to the temperature difference, and here proportionality constant is a small h, that is heat transfer coefficient. Okay, so this is a very important concept for your examination and interview and viva purpose, and this concept is also important for GATE examination where 2 mark question, 2 mark numerical can be asked based on this concept. Analogous behavior means similar behavior in another system. Okay, so this is all about this lecture. We'll see next topic in the next lecture. Thank you very much.